In this final video, we're going to trim away excess material surrounding these holes that we've made to minimize the size of the drive's footprint on the top of the skull and thereby maximize the amount of surface area on the skull that we have available to us for placing securing screws and binding the drive to the skull by allowing a lot of surface area for the bone cement to make contact with the skull. So let me go to my standard view orientation and look at things from the bottom here, and I'm going to zoom in, and here's Bregma, here's Lambda, and you can see the 6 holes that I've drilled. I'm going to come over here and I'm going to find this trimming sketch and left click on that and unsuppress the trimming sketch, and as usual you'll get some errors that you can ignore here, and you'll see the gray outline of this trimming sketch appear, and then I'm going to click trimming sketch again and I'm going to click edit sketch, and when I do that these gray lines will appear now in black. So now I am in sketch editing mode, which should be familiar to you from prior videos when we were drilling these holes. And now what I'm going to do is go up and I'll use my circle tool by clicking on the circle, and I'm going to center my circle on one of my hippocampal probe holes, and then I'm going to just pull it out to maybe about a millimeter or so outside of the circle, maybe a bit more than a millimeter, like that. And then I'll check that, and now I'm going to draw another circle around my other hippocampus hole, trying to make it about the same size. To judge that, I'll try to make it cross the midline by about the same amount. Doesn't have to be exact, but something like that. Oh, actually that's too small. So I've made that a little smaller than I want it, but I can actually adjust the diameter. It's 2 millimeters right now. I guess I could go up to, I'll try 2.1. Well, maybe make it 2.2. Yeah, that's more like what I want. So I'm going to say check. So now I've got these 2 holes that are about the same size around my hippocampus probe bundles. Alright, now what I'm going to do is I'm going to draw a boundary around one of these front holes that we've created for our nucleus accumbens probes anterior to Bregma. And since these holes are at a slight angle, I'm actually going to draw an elliptical boundary rather than a circular boundary. Since the bottom and the top of the hole are a little bit offset from one another, it's going to require an ellipse to surround this hole instead of a perfect circle. So I'm going to come over here and click on my ellipse tool, and just as when I draw a circle, the first thing I'm going to do is click the center of the ellipse that I want to draw and hold down the left mouse button. So I think I'm going to make the ellipse center be about here. And then I'm going to drag out, and it looks like I'm drawing a circle at first, but it will be an ellipse, you'll see. And so there's my top hole. It's highlighted in orange now. And what I really want to do is go about a millimeter past the outer edge of that top hole. So I'm going to come out to, let's say, about here. And then if I let go of my left mouse button and click it again, I can now draw the vertical dimension of my ellipse. So I'm not holding the left mouse button now. Actually, I just clicked once on the left mouse, and now I'm going to give myself about a millimeter boundary above and below the circle as well. So I'll do that, and that's about what I wanted. So now I'm going to hit check and keep that, and I'm going to try to draw another nearly identical ellipse around the hole on the other side. So again, I will first draw a circle, click, and now I can do my vertical dimension, and I will click, and that's about what I want. So I'm now going to go over and hit check. It doesn't have to be perfect, but we've got these 2 ellipses that are not quite identical but close enough surrounding the 2 holes in the front of the drive. Now I'm going to create another pair of ellipses surrounding the rear holes, which are also angled. So I'll go back to my ellipse tool once again and essentially repeat the process that you just saw. Make a circle first, maybe about there, and I'll make my ellipse about like that, check, and then do it again for this hole. There's my first circle. And there is I'm going to try to size it similarly to the one on the other side, so about like that. Alright, so now we've surrounded all of the 6 holes that we've created for the Pro bundles with these circular or elliptical boundaries. And just notice that these bottom 2 ellipses and then these 2 circles here are a little bit offset from one another because our holes were a little bit offset from one another in the anterior-posterior axis. So don't be disturbed by the fact that this doesn't look entirely symmetrical, because it's not supposed to. So now we're coming to the trickiest part of the targeting cone design process. My goal here is to create a boundary around these holes so that everything inside of that boundary will extend all the way down to the skull and make physical contact with the skull surface. And everything outside of that boundary is going to be trimmed away to make room for securing screws and for our bone cement to make good contact with the surface of the skull. So I want to make this closed boundary around the holes, but I have a little bit of a problem here because this circle and this ellipse do not intersect one another, and that creates a gap, and I can't make my closed boundary through that gap. So what I'm going to do is I'm going to come over here to this green square. This is an anchor that fixes this circle to the sketch plane, and if I click on it and hit delete, I delete that anchor, and then I acquire the ability to move this circle in the sketch plane. So I will now click and hold down the center of that circle and move it up until it does intersect this ellipse. And now I do have a nice closed boundary here. And now what I need to do is trim away all of these extraneous lines inside of that boundary. So to do that, I'm going to come over here and click Trim Entities. When I do that, I can hold down and drag the cursor across lines inside of this boundary and just melt them away, delete them away. And you can see that this is trimming away both the black lines and the blue lines because they're both part of this sketch here. And what I'm going to do is try to create this nice closed boundary. You have to practice this to get the hang of it, but I'm just holding down the mouse cursor and dragging, and everything that I drag across while I'm holding down that cursor gets deleted out to its next intersection with some other shape. So I have got the ability now to trim away all of these extra lines in here. And that looks about right. Oh, let me zoom in, and I think I need to cut away that thing. Yeah. So now you see that I have this nice closed boundary surrounding my holes, and that will be the footprint, the shrunken footprint of the drive on the top of the skull. So all the material inside of this blue boundary is going to remain intact, and all the material outside of the blue boundary but inside of this outer black boundary in this region here is going to be trimmed away. And in order for this to work, the internal blue boundary and the outer black boundary have to be closed, and I accidentally messed that up by deleting. There's a black line here you can see, and I deleted its partner over here. There is a mirror image black line on this side that I accidentally deleted when I was trimming. So I'm going to draw that back in. I can should be able to zoom in here and just draw that line back in like that. Something like that. Okay, hit check. And now I'm going to do a little more trimming. I'm going to trim out these so that now you can see the inside of this blue boundary is actually continuous with this. So the part that's going to get, I've got a little gap here, a little tunnel here that is not going to be trimmed away. This will be trimmed, this will be trimmed, but this will not because it's become continuous with the inside of my blue boundary. And I'll show you later why I'm doing that. Let me trim away other stuff here while I'm still in trimming mode. I think that these two lines, I'm not going to make a channel in the back, so I'm going to trim away those lines. And now I should be good to go with that. So I'll click on my check, and that's it. Now I think I'm ready for my trimming. So I'm going to go back to my Assembly tab here, and under Assembly Features I'm going to choose Extruded Cut. Once again, as before, I'm going to choose Through All Both. This is the same thing we did when we were drilling our holes. But now I'm going to tilt the view a little bit here so I can see exactly what I'm cutting. And this cut is going way too far. I'm cutting way in, and I'm going to cut a hole right through the bottom of the drive core. What I need to do is I need for this cut to stop right here. So for that, I need to adjust how deeply this cut is going to go. And you know what? For that, I actually need to go back to this blind selection here. Through All Both is not the correct choice for this particular task. And what I want to do is enter in 3.75 millimeters, because that's the depth of the cut that I need. You can see now that I'm just trimming off the material up to the bottom of the cone. I'm going to hit check. Let's see how this goes. And there we go. You see, I have trimmed away the material outside of the blue boundary and inside of the black boundary, except for this little trench that I left up at the top. Now I'm going to trim down that little nub there. To do that, I'm going to go to Assembly Features, Extruded Cut, and now I'm being asked to select a plane in which to draw a sketch. I'm going to expand all of my objects here and choose the trimming plane as the plane that I'm going to draw my sketch into. And now the sketch that I'm going to draw is going to be a rectangle right on top of that little nub. And when I do that, I'll click check. Then when I click exit sketch, I'll get a little error message here. I can turn to the side here, and you can see that I'm cutting way through here, and what I want to do is make the distance of the cut be 1.13 millimeters. Now you can see that it's just going to trim a little bit of the top of that nub off. And the reason I chose 1.13 millimeters is because this trimming plane, remember that we cut 3.75 deep down to this spot to trim away everything around our holes. But now I'm going to cut 1.13 because that's the distance between the trimming plane and bregma. And I want this little nub to be level with bregma because it's going to be useful as a tool for measuring the dorsiventral coordinates of bregma when I do my surgery. So I'll check OK for that. There's the cut. So you see I have this little ledge here that is going to allow me to measure the dorsiventral position of bregma so that I can gauge my dorsiventral coordinates when I do the surgery. So that's it. We've completed our targeting cone. This trimming step is probably the hardest part of the entire process, and remember that that trimming plane that we use to draw our sketches to do the trim is 3.75 millimeters offset from this base where we want to trim back to surrounding the holes, and it's 1.13 millimeters offset from bregma. So if you want to trim up to bregma as we did here to make a measuring tool, that's the depth of your cut that you're going to need. So thanks for your attention. I hope now that you're able to design your own targeting cones quickly and easily to do your own experiments, and good luck with your targeting cone design.